average velocity, let's call it V average, is also a vector and is defined as the change of the position, which is the displacement, divided by the time interval, right, during this process. And in the limit of delta t approach 0, we're going to get V average approaches an instantaneous velocity. Let's take an example to look at the difference of this instantaneous velocity and average velocity. Suppose we know a position vector as a function of time is given by t square I hat plus t j hat. Then the instantaneous velocity as a function of time is then given by dr dt, which is 2t I hat plus j hat. And let's also look at a point, let's say t equals 0 second. Then the velocity at t equals 0 second, instantaneous velocity is given by j hat. So its magnitude is going to be 1 meter per second, and its direction is along the y-axis. Okay, so now let's look at several average velocity for comparison. So let's say we're looking at time interval equals 1 second. So average velocity when we go from 0 second to 1 second is going to be delta r over delta t. And at t equals 1 second, we get I hat plus j hat minus 0 divided by time interval 1 second. So we get I hat plus j hat meter per second. So its magnitude, the average velocity magnitude, equals square root 1 square plus 1 square, so that equals square root 2, which is 1.4 meter per second. And its direction is also along 45 degree to x-axis, or 45 degree to the y-axis. Now let's look at a larger time interval, let's say 2 seconds. Then V average equals, so at 2 seconds we get 4 I hat plus 2 j hat minus 0 divided by 2 seconds. And result here is 2 I hat plus j hat in unit of meter per second. So we average, the magnitude here is 2 square plus 1 square, so that equals about 2.2 meter per second. And the angle here also changes, okay, to another angle, which is actually larger than 45 degree to the y-axis. And we can do this further. Let's say delta t equals 3 seconds. Then the average velocity becomes 9i plus 3j minus 0 divided by 3. So we get 3I hat plus j hat in meter per second. So V average now becomes 3 squared plus 1 squared. Okay, we get about 3.2 meter per second, and this direction is again further away from the y-axis. So now if we look back in the reverse order, then we can see that if you decrease delta t, then the average velocity approaches instantaneous velocity, which is 1 meter per second in this example.